Okay, on to number 4 that has absolutely no horizontal, but the mouse buttons work. And yeah, look at this. It's a different design as well. It's not one that you twist. It's one that you pull down. Look at the size. That ball is larger than the others. It's a completely different design. Let's try to move. Here's what happens when I move it back and forth. So it's probably not the cable. You know, obviously if one of the conductors of the wire, the cable that goes to the computer is bad, it's not going to have horizontal, I believe. Let's see if we can determine why it's almost dead. It's not quite dead. If it was dead, I almost would be better off, because it might be a little bit easier to diagnose. Yeah, this is a completely different design of mouse. This is interesting. I actually can't really tell. See, the buttons are on a different daughter board that sits above it on their own screw. This is interesting. I believe, if I'm not mistaken, the other mice had a single set of sensors, but this one obviously has 2 of these components on one side. Let's take it apart and see what we got. I imagine it'll just pop out. So isn't that interesting? Yeah, still just 2 screws. There's a daughter board for the buttons, and they're the robust size ones too. Oh yeah, this is doubled up on the sensors. You got one here and one there. So these early mice are made better. They're going to be more accurate or more reliable by having dual pickups, as it were. Everything looks pretty crusty here. Yeah, things are looking pretty crusty on that thing. Maybe what we have is a bad connection. Got some diodes in there and some SMD components. That is unexpected, because I don't believe the newer ones have SMD components, but there's a few on the back of this. They don't have any markings on them, so what they might be is just bridges. Yeah. Kind of curious about that. So the right way to do this would be to just start testing continuity. You don't need the mouse plugged in for that. Oh, one of the things I can do before I unplug the mouse is get some kind of a wiggle test going here. Yeah, no, that's really strange. So what's nice about this is that I have, let me unplug the mouse, of course. I have a working axis and a non-working axis, so that will allow me to compare. I guess I can just do a continuity test with here. Let's see. Yeah, whether it's supposed to be or not, this is, well, it's on the working side, so that's a bridge. That's not. That 245, 250, 250. Let me just range up here, and this is a resistor, I guess. 330 ohm. 330 ohm resistor. 1.5K. So, and this is just a dead short in both directions. Basically, what I was doing is, this is the axis that works up here, and this is the one that doesn't. And so I was testing these components. Let me see if I can zoom in and give you a better look here. So there's a component here that's blue, and it appears to just be a 0 ohm resistor, or a bridge, you know, because I get just straight continuity through there, 0 ohms. Yeah. This one here and this one here seem to be resistors. This is a 330 ohm. This is a 1.5. So I went down here to the one that's not functioning, and I measured this, and that is again a dead short. And just to see if it's a diode, move it around the other way, dead short. That's what I did above. And then this one here, this is laid out a little bit different. This one's supposed to be 330, I think. It is. And this one's supposed to be the 1.5, I believe. 1.5. Okay, so these solder joints are really crusty, and maybe I should examine this under higher magnification. I can double my magnification right now. You might see the side of my head. I can't. Oh, there's another resistor here. That's 830 ohms. The equivalent for that one is, I don't know, because there's two resistors here going to either the LEDs or the photo resistors, and I don't know if I see the same thing over here. Well, there are some numbers on these, but the important ones, I can't see anything. There might be a number on the blue ones, but here's one. Right, so these have to be the diodes, because probably they are, because they have resistors on them. In this case though, I couldn't find the second one. There's one here. Yeah, there's one here on its ground side. The other one I had to trace. It's actually over here. And I determined these actually should be the same value, because these are the same type. So this one's coming up at 1.8K. This one's coming up at 1.5K. This one's coming up at 1.5K. And this one is coming up at 830 ohms. You know, 0.8K basically. So I think perhaps I should replace this one. I don't have any SMD resistors, but I can put a through hole. I can probably get a through hole in there, because I can have it sticking out the side or something. I don't know. Just for testing purposes, that's what I plan to do. I'm going to replace that resistor with a 1.5 and see. Okay, as you can see, I bodged a resistor on here, so let's test our values. And now we've got 1.5, 1.486. So let's see if we get any signal from this thing now in its horizontal axis. I've got absolutely no signal now. Geez, maybe the diode is on this side because, well, no. Either way, these aren't actually behaving like a diode. I may have gotten my photo resistor confused with my LED because I actually think the LEDs are on this side. You got your 5 volts coming in, then a 330 ohm resistor comes across. And then the entrance, or probably the plus of this, I believe to be an LED, infrared, is 2.24 volts. And then exiting it is 1.12 volts. Now let's see what happens over here. The entrance to this one, 2.24, and coming out of it, 1.12. Okay. Yeah, I actually think that the LEDs are on this side and that the photodiodes are on that side. Okay, yes, the photodiodes are on the outside, and here's a cool test. So one side of the photodiode is 5 volts. The other side modulates when you spin the wheel. It's at a high of 0.26 volts, but if you move this a little bit, it drops down to nearly nothing. And then you move it some more and it goes back up, and vice versa. I mean, and so on, I should say. So here's the 5 volt side, and here's the other side. If I can get my probe in there. 5 volts. And that goes up to 0.31. So 0.25 to 0.31 on that side when I move it. Let's see. That's our 5 volts. This side, 0.8 going up to 1.5 or 1.3. Down to 1 up to 1.4. Doesn't seem like it's the same amount of voltage. And so what these resistors are is they are drop down resistors. It's dropping the signal coming out of the photoresistors. Who knows what the voltage would be without them. Probably too much for the chip, but apparently 0.2 or 0.3 volts is what the chip is looking for. There's an IC chip here where these signals are fed into, and this side definitely is lower than the other side. Actually, this is the same. This goes up to 32. I'm just spinning the wheel. This side here we should have it open right now, and it's not. 0.13. So this side is too low. The circuit, the output of this photoresistor comes down here, jumps over. This is a 0 ohm resistor. It's a bridge. And then feeds right into the chip at this position. The one on this side comes down and it feeds into the IC at this position. So this one and this one, that one and that one. And they're not behaving the same. They don't have the same voltage. The question is there something wrong with the chip that's dragging down that? Or is it the resistor? I tested the resistor and it seemed like it was of the appropriate value. But that's testing it in circuit. So maybe what we should be doing is testing it out of circuit. You know, what's interesting is they don't activate at the same time. This one is an open circuit and this one is partially closed. And when I move this a little bit, it becomes the other way. So I guess that's how they're getting a better resolution on the mouse, is by alternating between one and the other. There's a tab on this side that holds this side of the shaft in place. And when I was bending it out to remove it, I wanted to determine if there was anything blocking or anything stuck, like a piece of fuzz stuck in there in front of the photodiode, to see if that's what was causing the lower voltage. But you know, I got this shaft out, it busted one side, so it's mounted on this side, but on this side it's floating free, unfortunately. Okay, so again, I have a 1.K here. The next value up that I had, this was a 2.2K. The next value up I had was a 2.7. That didn't seem like enough of a jump. I kind of wanted to get into the 0.3 range of volts, so I went with a 3.3. And let's try to do this. It's a little bit difficult. So again, the way I do this to test this is I put my my positive, I'm on the ground or shield, or yeah, the ground plane of this board, and I'm probing on the sense side. One side is supplied with voltage, the other supplied is you know, and another thing I discovered is that this thing's only receiving 4.5 volts. There we go, 4.59 volts. I might have to look at the Amiga to find out why that's a little bit low. That's definitely lower than I've seen on there. But I've never had any trouble with joysticks or mice on this computer before, so maybe I'll put a note on the computer, a little sticky that says that it's 4.59 volts coming out of there, in case I do have trouble later. I can measure it again, and if it drops more, you know, there's a bad resistor or a bad capacitor or something like that. Anyway, so I've got a 1.5 here, a 3.3 here, and again, I'm going on the side of the photoresistor that goes to the chip, that, you know, the actual sense lead, and then I'm turning this very slowly until I get the signal. And now I'm up to 0.27, 0.33. And on this side, again, I'm up to 3.6, 3.7, something like that. So I think the ideal voltage is at 0.3, but the result is definitely marked. Focus. I now have a perfectly scrolling mouse. So if the reason why I needed to add higher value resistors to bring the voltage of the output of the photoresistor up is because of the IC chip that's on there, I imagine the problem might come back or or whatever. But at the moment, I'm not 100% sure if it was a bad resistor, because the resistors aren't marked, and so I don't know their values. They look to be 1.5, but you know, maybe this one is supposed. Maybe the two on the horizontal were both bad. One of them, they were both low. One of them was 800 ohms, and the other one was 1.5, and maybe they needed to be 3.3K. And you know, typically what you'll find is that all the resistors, pull down or pull up resistors, would be the same value, and that's kind of what I'm leaning towards. And perhaps the chip on this board needs to be replaced. So if I need to, I'll do a follow-up of this video, but for now I guess I fixed it. So I might continue this video too, because I'm not sure I can get these into the case. Let's see how that works. Let's take care of that right now. How well is this going to fit into the case? Some big old resistors on it. Do I have room around this edge? Oh, it looks like I do. Yeah, there's a gap. There's a slight gap on this side, a huge one on this side. So there really isn't a problem using these resistors and sort of bending them, having them have the body of the resistor around the edge here. Actually, I thought this thing was moving smooth, but when I move it to the left, I'm observing smooth movement on the wheel, the shaft, where the sensors are, but it is jerky. So I'm going to go ahead and see if I can get a replacement for that chip, because I don't think that's something that the photoresistors are going to do. I think that's something that the chip is going to do. I don't know, if this photoresistors aren't matched right, then I suppose it would cause this problem. I'm going to desolder that chip and see what goes. Okay, so yes, indeed, the problem was this shaft and this wheel with the slots cut into it that allow the light to pass through. I don't know if you can see that. I did show it earlier. Anyway, so as this disc right here turns, it's something to point with. As you move the mouse, it rotates this shaft, it turns this disc, and the disc has slots cut in around the edges, and it makes or breaks the signal between the LED and the photo sensor, photodiode. And you know, I busted this part. You can see my repair. I just got some pieces of plastic and sort of glued them together, and then took that little assembly that I'd made and hot melt glued it here in case somebody wants to pop it off. It'll pop off with just very little force and a knife. To keep this, because when I attempted to remove this shaft, of course this is old plastic, it's 30 years old, whatever. You know, the piece that was holding it in on this side just busted off. It was a finger that was in this inside a slot that you're supposed to pull out with something. Actually, coming in from the top here, there's a slot. You come in from the top, or you come in from the side, and you hold it out while You hold it away from the shaft. So the shaft is here. There's a piece of plastic that comes down and basically sits right on top of the shaft. You're supposed to move that piece of plastic out of the way so you can get the shaft out. Well, moving this plastic, I'm pretty careful about it. It busted off, and so there was nothing to hold the shaft in. And so I have to create, you know, something else to hold it in there. So now it's pretty good. Basically, this wheel needs to not, when you push on it, there's a slot on this side that you can push on. The wheel comes down through the circuit board. When you move this or push on it, it's basically supposed to have absolutely no deflection, and it did. It did. When I had the remnants of that piece that broke off in there, it had a little bit of deflection. Now, the reason why this screwed me up is because it was the exact same. Now, I had diagnosed a bad resistor here. It was 800 ohms instead of 1.5 kilo ohms, and it was causing the exact same symptom, where the mouse would just, the pointer would just jitter instead of move. It would just jitter like this. So after I replaced that resistor, at some point I attempted to remove that disc. I busted it. And ever since then it was never seated correctly, and I was chasing my tail thinking that it was something electronic when it was actually mechanical. So once I sorted that, and basically the reason why I figured out my mistake is because I've had that problem with mice before, and I just couldn't remember what it was I did to fix it. And sure enough, it was something about the how loose this shaft is. It needs to be very stable and so that it doesn't wiggle very much. So anyway, now it's a fully functioning mouse. I probably could have put the 1.5 resistor back here, but you know, what's the point? You know, it looks pretty good the way it is. It's reliable. I'm already going to have a resistor here. The only other alternative would be to get a couple of SMD resistors and put them in place. But I'm not going to worry about that. I mean, somebody who looks at this is going to know somebody did a repair. So the mouse is now fully functional. And so I had a double problem. I had a bad resistor that had its resistance was too low, and it was bringing that signal for that one side, for this side, it was bringing the signal down too low so that the chip wouldn't sense it. Oh, and by the way, the chip itself, it's a quad comparator. So it basically changes the 0.25 volt to 0 volt changes that these photoresistors create, and it basically works as an amplifier. It amplifies it up to a 5 volt signal and sends it out back to the Amiga. It's H pulse and HQ pulse, V pulse and VQ pulse. And as it turns out, it's close to the same voltage that's being inputted. It's almost, well, in this case, it's 4.5 volts being sent back to the Amiga, which seems to be enough. I'm only getting 4.6 in from the Amiga. So anyway, this chip here, I socketed it thinking that it was some sort of problem with the chip, but of course that whole time it was actually just a mechanical issue. But this is a 14-pin quad comparator, and there's actually several part numbers. I actually had a couple of compatible chips, and the one that is in the newer mouse has a different model number, but this is it. This is actually the one from, I have a newer mouse here, and it's a 10339. As long, I believe, as the model number ends in 339, an LM339, a 10339, I believe it's going to be the same. So I actually have an extra chip I'm going to use this to test with. But anyway, that's the problem with this mouse all solved. So thanks for watching.